Making stable ionic compounds requires that they add up to zero. That's really all there is to it. Let's look at a few examples of this. Okay, so let's say I have ammonium ion, which is an ammonia with an extra hydrogen. And when it's doing that, now these are using the flashcards, ion flashcards, which are available from Science Glen or from Amazon. Okay, that's NH4 plus. It's got an extra hydrogen, so it has a charge of +1. And you can see its shape, tetrahedral, and so on. Okay, it's a polyatomic ion that has a positive charge. Not many of those. Hydronium ion, ammonium ion, that's about it. Okay, so now it's got a positive charge. Now, using the Ionic Bond Disc Model, you can see that as well. Here we have, oops, like that. It's lost, or it's gained an extra hydrogen. It has a charge of +1. Okay, here's the name on the back and the molar mass. Now, if on the other hand we have bromide ion, which is a bromine, here see bromide, here's a name, and here's a bromine that has picked up an extra electron. It's gained an electron, and you can see the electron configuration. And it does that so it can be like the noble gas that's right next to it, krypton. Now, using the Ionic Bond Disc Model, here I've got a bromide ion with its wiggling electron, and bromide ion, the name and the molar mass. Now, if I combine these together, I have a plus and I have a minus, and they stick together. And so you have +1 minus 1 adds up to 0. And the formula for this will be NH4Br. Simple. But what happens if, let's say that we have something that has a charge of 2 minus? Well, if we look at sulfide, sulfide picks up 2 electrons, becomes 2 minus. So using the same thing, and I have a version here that's got 2 minuses on it, using the Ionic Bond Disc Model, and here's the name, sulfide ion, and the molar mass. Okay, well, okay, that works, but I still have an extra one here, so I need an extra ammonium. And so now I've got it. Let me see if I can pull it back so you can see it. There it is. Okay, so that would be parentheses NH4 n parentheses 2s, because you've got 2 ammoniums. Now again, it adds up to 0. I have +1 +2 -2 adds up to 0. That's it. You want to get to 0. Now let's take it one more step to more even extreme. Let's say that we have a phosphate ion. Do you know what the formula is for phosphate? Can you guess? It's PO4 3-. It's got 4 oxygens gathered around a phosphorus, and it has an overall charge of 3-, and it has a tetrahedral shape. So, and again, here we have the Ionic Bond Disc Model, and it's got charge of -3 around it. Okay, 3 extra electrons sitting around out there. And so I'm going to need how many ammoniums? 1, 2, if I can pick it up, 3. Here I have it. Oops, getting the camera there. 3. And so this would be open parentheses NH4 n parentheses 3 PO4. And again, +1 +2 +3 -3 adds up to 0. It always has to add up to 0. That's really all there is to it. You want to make sure that when you're making an ionic compound, it adds up to 0. And when it becomes a crystal or in a crystal lattice, all those things balance out and you end up with a balanced, non-charged compound. All right? Ionic compounds have no charge. The ions have charges, and they come together in a way that adds up to 0. All right? Okay, so if you're interested in getting the Ionic Bond Disc Model, it's available on scienceglen.com, and you can go to the lead page.